Hi everyone, I am Junaid Ahmed. I lead Dev Experience and APM here at Datadog. APM stands for Application Performance Monitoring. It's a suite of services that enables performance monitoring from back-end to front-end services across all stacks and all operating environments. Our mission is to create specialized views in addition to application performances to get into databases, user sessions, as well as other specialized views. Today I want to talk about the latest developments in the application control plane, which makes it easy to start as well as advance your application management journey. Hence, the content of this talk is relevant to new developers who are starting their observability journey, as well as developers who've been leading the cloud and running applications in the cloud for a really long time. Throughout the talk, we remain to stay in a very real-world setting where the challenges of today make it harder to imagine a better tomorrow. We'll have demos for the concepts presented, and we'll also share some practical lessons from our own experiences at the end. So with that, let's get right into it. So we all know what it feels like to ship with confidence, but what does it really mean? It means that the developers and on-call engineers understand how services connect with each other. It means when changes are deployed, the effect on the application can be understood quickly, and investigation takes minutes instead of days. It's when we can understand any user journey throughout our application stack. It's when we can correlate issues from infrastructure, external dependencies, so that precious engineering time can be spent in growing the business. However, the state of many application planes looks more like this, right? Where developers and SREs spend way more time debugging issues. Teams continue to fix symptoms rather than root causes. Incidents and issues can easily get lost in tracking. Innovation is slow. Engineers as well as customers are frustrated. Now, there are many reasons for this, right? But one which I wanted to delve deeper on, it's part of scaling up your organization. As the organization scales up, the on-call experience and the service management experience is bound to become worse. The scale leads to complexity and creates widening experience gap. A veteran in your organization may know exactly all the tribal knowledge and all the context. But what happens when a relatively new engineer is faced with an on-call issue and they have to find the issue across dozens of services, across hundreds of engineers, many teams? How do we make sure that the data gets to the right engineer at the right time? And how can you correlate it with the real-time observability data coming in to figure out what's going on and to solve the root cause? How can your new hire operate as a veteran in managing applications? And that's truly what the journey and what the challenge is all about. So to summarize, the real environments are hard to monitor for a number of reasons. We talked about legacy systems just now. There's also neophobia, like the culture of not knowing observability tools in some environments. And when you are making an upgrade to your applications to get instrumented, you have to coordinate those changes across multiple teams, right? And coordination is hard. Every team has their own schedule, so it becomes hard. And then all of this adds to the cost of upgrade, right? And at the end of the day, the teams are left with yesterday's tools to solve the problems of today and tomorrow. So to summarize, the premise we want to state is that deep observability truly matters. It matters for a number of reasons, but the main one being that it leads to a strengthened engineering culture where you can ship frequently, ship confidently, and focus on growing your business. So how do you practically start, and where do you start? Let's get right into it. So the approach that we've put forward is loosely bucketed into 4 categories. First one is service instrumentation, right? Which is the act of enabling all your services to be instrumented as much as possible automatically without changing too many things. Once your applications are instrumented, you get into metrics and traces, right? So without changing, again, too much application code or adding too many metrics, how do you get out-of-box visibility into your applications in real time? Then comes correlation, and we're going to talk more about this in the demo as well, but the power of correlation is being able to look at an issue and correlate it with an infrastructure issue, with some other dependent service. Like the power of correlation is huge. And then discovery. Once you've instrumented all your applications, the observability muscle should enable you to find information that you were not looking for, right? To make the culture even stronger and to enable you to discover things that makes your application even more robust. So now let's get to service instrumentation. So service instrumentation is not a new concept. I'm sure many of you would have instrumented your services with a runtime, with a tracing library, with a metrics library. So all of that is well known. We're going to focus here on low effort service instrumentation. What's low effort? To be precise, what we mean over here is low effort which does not change any application specific code, right? And the reason we believe this is a powerful enabler in starting is because when you're changing code, you then have to coordinate. You risk introducing bugs. You risk, expensive upgrades. So how can you get started without changing the application code at all? We're going to talk about 3 techniques here, and there'll be more details. And those are eBPF, admission controller, and OS runtime. Very briefly, eBPF allows you to sniff network packets and determine the throughput and error rate of your application on the fly. We're going to talk more about all 3 of them. Admission controller is the capability of controlling how your pods get instantiated and deployed. And OS runtime is basically for your containers and VMs when you're running without Kubernetes, and it enables more deeper instrumentation. If you had to just compare the 2, super high level, all 3 of these techniques lead to service discovery, right? So you don't have to really know all your services. These techniques allow you to instrument all your services. From a metric standpoint, eBPF gives you like red, which is basically errors, rate, and duration metrics, because it is tied with the function calls. The admission controller and the OS runtime techniques are actually attaching a runtime into your applications on the fly. So they are basically changing the binaries without changing the code. So they can give you beyond red metrics, tracing, and other capabilities that you're familiar of by the APM suite. And then there is coverage, right? So eBPF would work for certain communication protocols, admission controller would work for Kubernetes, and OS runtime would work for certain operating systems and certain languages. All 3 of these capabilities are in public or private beta. So after the talk, we would love to work with any one of you starting their observability journey, where you can try instrumenting applications on the fly and basically hardening these offerings as we GA them. So eBPF, let's go in a little bit more detail. So eBPF stands for Extended Berkeley Packet Filter. BPF defines the type of network packet filter implemented as a virtual machine that can run in the Linux kernel space. Before BPF, packet filtering used to run in the user space, which is not very efficient. But through kernel level filtering, we can process and attach networks together, the packets, very efficiently and quite fast. The newer technology also lets you add hooks to kernel calls, syscalls, and functions, including network-related functions, to provide visibility into traffic payloads and function success results, like success and failures with respect to all endpoints within the system. With eBPF, layer 7 packet processing can happen when most of the application protocols operate. So we can basically, with respect to a protocol such as HTTP, gRPC, you can actually connect the pieces of the calls together and really know what's a success, what's a failure, what are latencies, and whatnot. We're going to look at it more in a demo as well. Admission controller. So this is like, I'm sure many of you would be aware of Kubernetes. It's one of the most popular control planes today, running on AWS. Kubernetes admission controllers are plugins that govern and enforce how the cluster is used. They can intercept API requests and make modifications to how your request object works, right? So in this case, what we are doing is we are intercepting a call of starting of a container, and then we are injecting APM libraries before the call is instantiated. So you're basically adding instrumentation and runtime without really changing any code. The effect of it is exactly like adding a jar file in a Java library or a node package when you're instrumenting your application manually, but this happens automatically and supported by the Kubernetes infrastructure. Now, Kubernetes admission controller is a Kubernetes concept, right? With an observability vendor like Datadog, the Datadog's cluster agent, which is basically the cluster manager of Datadog, talks to the Kubernetes admission controller to make it happen end to end, right? So as you are invoking and as you are starting the instrumentation of the services, like a pod is being created, a pod is being deployed, we can intercept requests, rewrite environment variables, initiate commands, and the services would be running with instrumentation turned on. And this is more of the flow that what happens. As you can see, the admission controller over here is detecting a pod creation as long as it's created with the right settings, and then we're adding environment tags and instrumenting your service. Of course, because this is a mechanism supported by Kubernetes, deployment and rollouts can be managed throughout your environment where it manifests the way you're generally used to maintaining your application control plane. Now, moving on to a non-Kubernetes setup, OS runtime primitives enable you to work on other types of application control planes. So runC is basically a lightweight portable container runtime at Linux, which is supported by Docker. So if you're running a Docker container, it includes all the plumbing code used by Docker to interact with system features. It is designed for security and large-scale production use. And when you are invoking it, behind the scenes, we are adding environment variables, adding volume mounts with tracing libraries, and instrumenting your application. Again, the effect being the same. And if you're not on a Docker container on a bare VM, the exec v family of functions can be used, right? If you are unable to detect the language at container time, we can intercept through execve and again attempt to detect the language, rewrite the environment variables, and then examine each process as it is launched. So that's another way of instrumenting your code on the fly, depending on what fragmented set of control planes you're dealing with. And once your services are all instrumented, the power of being able to resolve issues and see the effect of issues, it shows up in a variety of ways, right? And I wanted to start by service topology, because that's a common use case, right? If a service is going down or is facing issues, how do we know who to contact? How do we know who do we work with to resolve? So service topology and the dependency map is the first step in getting there. And you get this service topology, again, without changing any application code. Just by instrumentation, you should be getting these capabilities on the fly. And that's a pretty neat start to an observability journey across the board. Once the services are instrumented, let's talk about metrics and traces. So we've seen that the red metrics are a start to just knowing whether your application, what it's doing, how many requests are getting, latency, and others. But what is even more powerful is being able to correlate these red metrics with respect to the version of the code that is running in production, right? Because all changes, most changes are the reason behind lifeside issues and incidents, right? And you want to know the correlation of these metrics with respect to what you've deployed, what is the other version of the application, what's the infrastructure doing. So there's a lot there. And then when the metrics are created, there should be an easy way to set up SLOs and SLIs for your service as well, which we're going to talk about in more detail later too. Distributed tracing is a very powerful tool that can also be gotten out of the box once you've instrumented your application code, because your application code, even without custom instrumentation, depends on popular frameworks that could be supported by the libraries that we ship. So you're going to get a full view of the time trace across all of your applications with respect to a user flow, right? So from the start of the user journey, which could be an API gateway, to how it affected a database call at the end and how things timed out, that entire view is available to you through distributed tracing, which is very hard to replicate if you were to manually do it through logs. Like I've tried to do it as a developer in a variety of ways, and it's very time consuming, and this can actually reduce investigation from days to minutes. We've seen, and we're going to see a demo about this as well. In large organizations, service ownership is a big issue. Like when you see issues and you see errors and you see external dependencies, how do you get to the right information? So getting to the right information through the ownership of cataloging of the services is important, and that view, you don't build this view automatically, but at least you know where to start, right? Because you see all your services, you see the view, you can start putting in the information, and then the richness helps you get to the bottom of the services that need to be contacted with. Live search and analytics is again a capability that if you've instrumented your code automatically, the fact that they can be pushed in and you can search and correlate data with respect to a filter or with respect to another application that is calling this application, the effects are pretty incredible. Like we see a lot of time saved in searching for issues and in able to analyze what the application is doing. Now moving on to correlation. When there is a blip in infrastructure, my personal experience has been that we spent days chasing down the instance of where the application was running, what the VM was doing, getting the logs of the VM, and then trying to root cause exactly what's going on. But with correlation capabilities that can come up out of the box, all these investigations take a really small time. These issues in a distributed environment can suck up an entire team's bandwidth. And the first step in operating the environment confidently comes through the ability to correlate across all of your applications. Error tracking and the ability to separate signal from noise is very important. If you've lived the journey of a front-end development environment, right, there are many errors that are spawned all the time. Not every error is very important. So correlating the top error, the top issue to the top and enabling the developers to focus on it has a really powerful effect. And error tracking helps you get there. Deployment tracking, we've talked about this in the past, but the ability to track deployments and do version generating on the fly is super important because this is what powers the version tracking metrics that we talked about earlier. And moving on to learning and iterating, with AI ops and with the ability of us to make sense of all the data across all the applications, a core, like an intelligence engine can help you find issues before it really affects your customers, right? You want to know about anomalies before it becomes an incident. And it's possible because we are seeing these graphs over hundreds of customers. So there's some value in building these capabilities out of the box. Similarly, forecasting, being able to correlate and say that, okay, your metric should have been going in that direction and it's different. Getting that insight in front of your developers, it helps. It helps being ahead of the issues. Version tracking, being able to track every version independently across all your applications. And then SLOs and custom metrics, which basically we're going to talk about more. But the importance of assessing service level objectives for your application and making sure that your entire organization is accountable to those is very important, and this helps you get started. Once your applications are instrumented with runtime capabilities, you can imagine that you can do things beyond performance, right? And the likely next step is security, right? Because we know as part of the instrumentation what libraries are being running, what versions are running, and what versions are vulnerable. So this can actually create a dashboard view for your organization around all the vulnerabilities that exist in the application control plane. Things that you may not be looking for, but are super valuable to know, and super valuable to know before they become a real problem. And this is, like, we can't get into all of this, but the observability journey starts with vanilla microservices, but there's really no end to it, right? Because as you get into more specialized use cases, there's more information that keeps getting added and keeps getting correlated, right? So you can imagine a world where you're running a SQL Server instance and you want to debug why certain queries are slow. So then from application, you can pivot into the database view and start debugging and start optimizing your databases. RUM, or Real User Monitoring, enables us to monitor user sessions very meticulously. And that gives you access to exact sessions that are happening across the board. So there's more to it. We can talk about this more offline, but we believe that this is just the start, right? You start your journey, and then you keep optimizing wherever you see value for your business. So with that, let's get into a demo. So we have arranged like 3 demos. The first demo is going to focus on the eBPF and the Kubernetes admission controller, which we're going to start shortly. The second demo is about VMs, and the third demo is me going live, and we're going to look at what happens when everything gets stuck together. Let me switch to the demo screen. Okay. Can everybody see the screen? Excellent. So basically in this demo, we are demoing an e-commerce app. It's called Bits Boutique. Imagine it's a new e-commerce app that you're acquiring in your existing organization. It's a regular e-commerce app. It has a notion of a catalog. It has notions of product pages. You can add things to the cart. There are categories, just a regular app. This app is deployed via a EKS cluster, and it's composed of several microservices. And I'm going to wait for the video to be catching up as well. So basically, these are the steps of the demo, where basically we're going to connect to an EKS cluster. We're going to issue and get all the pods. We're going to deploy the Datadog agent on all the hosts. And then we're going to see what we discover about this application. And then we'll try to enable APM and then see what extra information do we get. It's all shot in a single shot, and I hope we can all follow it together. So right now I'm trying to show that the environment variable for these applications is Bits Boutique reinvent, and there's nothing there. So you're starting with a clean sheet of paper, you've got nothing, and now you're beginning kind of your journey, right? We're using the AWS Vault command line tool, which I'm sure some of you are aware of, which enables you to basically issue commands to EKS and get more information about the cluster. So over here, we just got all the pods for all the applications that are running. As you can see, there are way too many services for that e-commerce app. We also have site load generators, so we are simulating a lot of errors and simulating traffic for this demo. And now we will deploy the Datadog agent through a very simple command, which we're going to look at into more detail, but let's execute the command so that the agent starts getting deployed. And then we're going to look at what the Helm chart of this deployment looks like. So now Datadog agent is deployed. It's listening on this port. We're opening the Helm chart setting of what we've deployed, right? So the Helm chart is pretty simple. We are setting up the environment. So dddev is the name of the environment. We're going to show the information to be found. Bits Boutique reinvent is the environment tag that we just showed. We have turned on APM. The socket and the port enables APM. And service monitoring, this is our limited beta offering of USM that enables eBPF style tracing for your apps. And there's cluster agent set up with 2 replicas, which is basically the cluster manager, which is talking to the admission controller, right? So we've deployed that too. So now let's try to see what's running on the EKS cluster. And now you can see there are a few Datadog agents running, right? So just the Datadog names are the host agents, and then the Datadog cluster one was the cluster agent. And you can see all the other pods also running kind of the way they were. So now we are going back to our portal and seeing what we found. And now, through all of this, we are able to now discover the services running on those pods. Like these services were not there, they were just discovered literally a minute ago. And you got that with no changes to the code, literally deploying the agent and discovering all of them. And each one of these has the basic metrics being plugged in. So the bar that you're seeing on the right is just that what we found. The earlier bar is from a different demo setup that we were doing while we were recording this, but it's getting you the metrics, it's getting you the red metrics information, it's connecting to the traces as well later on down the road, and all the information is available. You can see that there's version tagging set up as true. You're seeing that the log management is set up true. So basically, whatever we could do in terms of getting the services ready, we are able to do it, right? And as I'm going to refresh this multiple times, you're going to see more services being discovered, right? As we are sniffing the packets, as we are attaching the right packets, as we are getting the information. So order service is a Java service that is running as well on the pods. So kind of moving on a bit, now we are trying to enable APM library injection through the admission controller. So what you saw before was the eBPF setup of just network packet monitoring. Now we are injecting the APM runtime into all these services through the admission controller, again through a simple AWS Vault command. And now you can see these pods getting patched. And let's open basically the script to see what we've done. It's a very simple script. We are injecting the runtime of APM into all the Java services. That's what we've done. So it's basically using the Kubernetes command line parameter to patch and deploy the pods with the Java setting. And now when we get the pods, we can still see all the pods running as is. But, and now to figure out what's more going to happen, we will be moving to our traces view. I'm showing that there are more services still running. Now we'll be moving on to the traces view soon. So it would take a minute to get the traces in because the services are just deployed. While we wait, we would be actually switching to show you the premise of the next demo where things would come together. So I wanted to actually walk you through the Datadog interfaces as well. So this is basically the dev environment we're in. In the next demo, we're going to see all the applications working together. Where we're going to move to the demo app. So moving to the demo app in a second is where you're going to see all the richness of all the services that are deployed with all the service information there. So we're going to get to a lot of detailed information in a moment while we wait for the traces to come up. This would be the service catalog. Like there's going to be a lot of data that we'll be seeing shortly. And now going back to the dev environment, you can see the traces showing up. So these are the distributed traces from APM coming in within minutes, and you can filter them based on settings. We're going to be opening up a trace as well and showing you how the full trace looks like. And this is how the distributed trace is going to come together. So pretty much we are at the 8-minute mark in the demo, and then we started kind of setting this up at 3 minutes. So within 5 minutes, you were able to set up your applications with eBPF to discover all the applications, and then with APM runtime to instrument them, and then you've got access to a lot of information that is there in the portals already, right? So this was one, and then kind of moving on to the next demo. Here we wanted to show you applications that don't run on Kubernetes, and we don't discover them through eBPF. Like how do we go and just instrument certain apps out of the blue? So we are demoing one Node app and 2 Java apps, where basically you can see within the Node app, the package manager does not have Datadog. Within a minute, we should be able to instrument these. So we started the Node app, and when we are starting it, we are intercepting the calls, adding the Datadog API and the libraries to get more details. This is moving to the Java app, where the Java app has no relationship with the Datadog packages. But when we're going to start it, if you watch closely, you're going to see the Datadog libraries being injected. It's right here. So this is the first Java app. And then we're going to also instrument the second Java app and have these toy services talk to each other to see what information we actually get. So now we are adding, after we started all the apps, we'll be adding a few curl commands to add lists from the Node app to the Java app, so we can see the traces. Java app has started. And now we're adding the curl commands to add to the list. So basically it's a list being transferred from one app to another just to simulate some kind of traffic. And then at this point, we should have the traces as well, as you can see here, right? So again, within like a couple of minutes, you're able to get all the rich information pretty quickly. And with that, if we had to see how this all comes together, I'd like to take you to the APN portal with our demo app here, where basically you can just start off with the service catalog. So this is basically a big e-commerce application, Shopist, that has all the information stored in it. We start with the map view, where you can see pretty much all the apps that are talking to each other. You've got the web store app, which is in the center of your APIs. We've got advertising apps, the Shopist apps coming together. We see that the web store app is red, so we can actually go and inspect it real quick. You can see this is like a big set of dependencies across the board with incidents being called out. We can go deeper into the web store app, and we can say that I want to look at the service overview to see what's going on. As you get into the web store, you see the traces. You're seeing the red metrics with respect to the versions. You can come and you can start debugging further. Now we can see that from an infrastructure standpoint, we don't have too many issues going on. So what is really new over here is that one of your endpoints for your Shopist app, the checkout endpoint, is facing a lot of errors. This is where bubbling at the top error really is valuable. And then how do we get deeper into it? You basically go into the resources view, which is again auto-generated, where we can go into the checkout view and basically start getting into the details of what's happening over here. And we saw there was a spike in latencies in one way or the other. So I can pick a spike, and I can look at related traces of that spike. And now you're seeing the live search and analytics capability that I talk about. And you can increase and filter your traces appropriately. And this is giving you a sense of basically, with respect to that trace that we just wanted to investigate, this is where all the things are coming together, across the board. Going into the error track, you are able to find that there are many errors in the system, but there is inventory API, which is basically failing to put inventory into the system. And getting there, you can get to the next level of detail of the fact that you had a bad deployment, you couldn't kind of roll it. There are basically things that had to be rolled back. The information is kind of here with respect to the latency and with respect to the versions coming together, right? And where is inventory API? We can go into the service catalog and start finding the details of inventory API as well, where you can see the ownership information right here, and you can contact and get to the next level right here. Showing you maybe just one other thing I wanted to show was the ability of watchdogs. For that, I'll pick up another service, the address service, where we have a very interesting use case to talk about. If you get into the address service over a longer period of time, you can actually see watchdogs give you the full view of an entire lifecycle incident from start to finish. And you can see that an incident happened, and the full summary is provided here by the watchdog views as well. And again, it is the same elements of information we just talked about connecting together to make this happen. Not only can we do all like the system level metrics, you can actually go into the users view and look at all the users that are impacted right here, right? So you can look at the views, which is basically a real user monitoring view. You can actually go and look into the real events that caused the issues, how they surface for the customer, and you can replay some of those views to investigate and then later resolve. So there's a lot that we could be doing, and we'd be happy to show you more. With that, I wanted to move back to my presentation. Let's see. And invite Ariel on stage to talk about Starbucks observability journey and her experience with APM. Ariel, all yours.
Awesome. Thanks, Junaid. Well done. It's a hard act to follow. Those are some really cool features that I'm really excited about that are in beta and soon to be public. Holding him accountable for that one. Great. So hi, everyone. My name is Ariel Allen. I work at Starbucks. I've been with Starbucks for about 4.5 years. I'm a director of engineering. And let's talk about what I support. So I support the platform as a service at Starbucks. We are predominantly running in AWS. And my team, one of them, provides a platform in which our tenants run critical services that some of you may know. So Starbucks Rewards. Starbucks Rewards for Japan and North America. If you use our mobile app and you acquire stars and get free things, your transactions are running through our platform as a service. Other tenants that we have are also a couple steps of our critical workflow for mobile order and pay. So if you place a mobile order, when you hit that submit button, that runs on a tenant that's running on our platform. They process it and send it to fulfillment. Why I call that one out in specific is because that is 1 to 2 to 3 steps of a critical workflow. That service was created about 4 years ago in Greenfield, and they had to inject it into a already established critical workflow. So one of the challenges that that team had was explaining their health up the stack and down the stack. That's where me and my team came in. So not only do I support the platform as a service team, but I also support the SRE team, which is only an enablement SRE team. So they do not own production state. They are the experts in the area of production excellence, and they partner closely with our tenants and our platforms as a service team to make sure that we are not only monitoring and alerting on our platform, but how can we better run our tenants on our platform and drive efficiency. To do that, we've been partnering really closely with Datadog and actually have been giving them some pointers on things we want to see better on some of those features you just saw Junaid present. So we're super excited about that. All right. So we started with SLOs. So when I first started, all of our logs were in Splunk, and they were logs. They were not metrics. So when we had to talk about what is an SLO, I couldn't get anybody's time to even talk about SLOs. By time, I mean like the service providers, the service owners that we call tenants, couldn't get their time. They're too busy building it. So I said, all right, what's your front door? We're going to look at your front door, and we're going to start out with something that everybody has, HTTP codes. Is it a 500 or is it a 200? Let's start there. Let's just chart that out with your logs. See that? OK. I'm going to go present that to the service owner. Hey, what do you think about that? Right now, I'm going to call your SLO 98%, because 98% in this last 30 days of you running, you have had a 98% success rate. They instantly told me about known errors or OK 500s, which I did not know was a thing. So we then got to meet and talk about what are better ways and what are ways that we can filter those codes down to be more accurate towards our health. But the point there was we started somewhere, and we showed them data that got their attention in a way that we could have a constructive conversation. My emails were going unread, my Slack messages were going ignored, and they really didn't know who I was when I was like, hey, I want to talk about health. But when I came and showed them that 98% for a month, they said, no, we're better than that, we are better than that, let me show you how we are better than that. So by partnering together closely, and that's what we do here at Starbucks, is we partner closely. That's why I call them my tenants. I don't call them services. I don't call them my customers. I call them my tenants, because there's an agreement when you run on our platform as a service that we provide services to you, and then you also are held accountable for your service as well. All right, so SLO versus SLI versus SLA. You all are our customers, I hope. If not, download that app. So you would hold us accountable for an SLA. Internally, we don't treat each other like customers. We treat each other like partners. So that's why it's an objective. We speak in those types of terms. We use indicators to actually know what our SLOs are, and we actually set up monitors and alerts on those as you can kind of see those monitors over there in that image, to let us know if we are slipping on our SLOs and what is our error budget. Could we use these during an incident? That's why there's a question mark. Yes, and I do another question mark. You're not really going to dig into the real error on an SLO, but you're going to know that there's something wrong. And you can also trace that your error budget is increasing, and so therefore you actually have something going on, whether that's upstream or downstream of you. So how do you know that? Especially if your service or my tenant is sitting in the middle of a critical workflow, and let's just say that you hit that order submit and you got the spinning arrow, spinning circle of death. Is it my team? Is it my service? Is my platform good? What's going on? I don't know. Let's take a look at our services upstream and downstream. I already went over defining SLOs. Sorry, team. We'll come back to that in a second. All right, there you go. Upstream and downstream. So we sit in the middle of a critical workflow. We're going to look at who's ingesting us, and we're going to look at what we're ingesting. And again, we're doing it in a standard way across SLOs. So this empowers our services upstream and downstream of us to tell us what makes them healthy. How are they healthy? This isn't us just assuming we know what is right or wrong. That goes back to my other known error thing. So if I see these errors, I don't need to worry, but I need to worry about these errors. Instead of having to have that conversation individually with every single service owner, every single tenant, we provide an opportunity for them to build these SLOs, share these widgets across different child accounts at Datadog, and then we are able to add them to our dashboard so that we could see. So if we're turning red, are we upstream or downstream? Are those red? Very, very simplistic. It also draws the attention to people that are just looking for an overall health score, not looking to solve the problem. So you have engineers that are getting paged about actually what's going on, and then you have more of those report outs, let's just call it board members, that can then know what is your health score without actually having to ask what's that specific detail, what's that error, somebody go reboot that server. Nope, they can just know what the health is from a very simplistic green and red that again is all manufactured by those tenant teams and provide that service ownership. So you can show up how you want with your service. So let me go back to that defining. Maybe, there we go. So yeah, like I mentioned, you want to study the data and find out some reasonable metrics to show your system health. That is a partnership. That should not be something that you are auditing your services. You shouldn't be bringing them into the room and be like, what's going on here? Instead, as a partnership, discuss, learn more, and then actually provide an ability to show that with metrics so that you don't have to have this conversation over and over again. You don't have to update a knowledge base article. It's all right there. And then label them correctly about what are those endpoints. So again, if somebody, say a VP, wants to just look at the health, they can say, get expiring points. Well, I know about that. That's expiring stars. Okay, so I think I could probably figure out what the customer experience is if that's red. So that's another key thing there is use English words if you're native English companies, but use a very common language at that level. All right, go back to that. All right, so there's always work to be done here. And this is definitely a call out from my Datadog friends. How do we do service mapping and traceability across multiple child accounts? So at Starbucks, we have multiple child accounts within Datadog. And right now, sharing those metrics across is really just creating a public widget and adding that to a dashboard across accounts. But that does limit when it comes to tracing and kind of the stuff that Junaid was talking about. So we're continuing to partner strongly with them to encourage that and build that. Adding financial numbers, so something that we saw there with the APM features that Junaid was showing. We saw SLOs, we saw all the 4 golden signals, but we didn't see financial impact. How cool would it be if I could actually see what are my orders that are not getting through? What are my orders that are getting stuck? What am I missing out on? Obviously, I get asked that question after the fact, but it's good to see that right up top too, and it also helps you prioritize as well. You may be seeing errors, but if the customer's not seeing it and it's not impacting the critical workflow, then you can better prioritize that issue and possibly not burn out your engineers. So it can be used in more than one way there. And then how might we troubleshoot this just beyond incidents and impacts, right? So why wait for the incident? Why aren't we just constantly trying to grow and improve our everything, our latency, our error response? What are things that we could do to make us more efficient, maybe even more earth conscious? Things like that. So I think a lot of these metrics can really unlock that as you're looking at it more, even beyond just incidents or something's broken. And then I kind of already called that out, end-to-end transaction tracing. At Starbucks, we definitely enable you to own your service. Therefore, we have a lot of different ways to show service health and to provide metrics and logs. So doing tracing throughout that, especially since we're a decently old company, is very difficult, right? Because you're also dealing with a lot of legacy systems, and how do you actually have one common thing that you can trace end to end, and then add, like I mentioned, child accounts. I told him I wasn't going to beat him up too hard on the child account, but how do we keep tracing that across the board to really unlock all the things that Junaid was talking about? So yeah, that is what we are going to do, and we are looking more to do at Starbucks. And then I really like this slide. So I saw this at Dash. I just really think it's a beautiful picture of our relationship partnering with Datadog, and we do see them as a partner, to build this constantly asking for improvements, constantly trying to give them our feedback of how we would do that. And we just really love their iterative approach about that, because I think that's the best way to get things done is iterate and keep going round and round and round. So Junaid, I'm going to welcome you back up. Unless I think we can do some Q&A, or do you have some closing thoughts?
Yeah, so my mic? Is my mic? Okay. So basically just wanted to add to the same point that Ariel was saying, the loop continues going on. There is no end to it. You'll always find opportunities to optimize your applications, add more information. So thank you so much. This was awesome. And please, I've been told to remind all of you to complete the survey in the mobile app. We'd love to hear from you and then revise the content and GA these services. Thank you so much.
Thank you.